I hope you would have understood our previous session about basic aerodynamics. Let us start off with the continuity equation in this session. The laws of aerodynamics are formulated by applying the below principle to a flow gas. Principle states mass can neither be created nor destroyed, hence the mass is conserved in aerodynamics. Now let us look at the streamline that goes through the circumference of the circle. These streamlines form a tube called a stream tube. As we move along the gas confined inside the stream tube, we see that the cross-sectional area of the tube may change, say in moving from point 1 to point 2. As long as the flow is steady, the mass that flows through the cross-section at point 1 must be the same as the mass that flows through the cross-section at point 2, because by the definition of a streamline, there can be no flow across streamlines. Let A1 be the cross-sectional area of the stream tube at point 1. Let V1 be the flow velocity at point 1. Now, at the given instant in time, consider all the fluid elements that are momentarily in plane of A1. After a lapse of time dt, these same fluid elements move along the distance of V1 dt. In doing so, the elements have swept out a volume A1 V1 dt downstream of point 1. The mass of gas dm in this volume is equal to the density times the volume. That is, dm is equals to ρ1 of A1 V1 dt. This is the mass of gas that has swept through area A1 during the interval dt. Now, the mass flow m1 is equals to ρ1 A1 V1, which has a unit of kg per second or slugs per second. The mass flow through A2, bounded by the same streamlines that go through the circumference of A1, is obtained in the same fashion, which says m2 is equals to ρ2 A2 V2. Since the mass can neither be created nor destroyed, we have hence ρ1 A1 V1 is equals to ρ2 A2 V2. For example, consider a streamline of flow over an airfoil. The space between two adjacent streamlines, such as the shaded region, is the stream tube. The equation ρ1 A1 V1 is equals to ρ2 A2 V2 is applied to stream tube, where ρ1 and V1 are appropriate mean values over A1 and ρ2 V2 are appropriate values over A2. The velocity V1 is assumed to be uniform over the entire area A1. Similarly, the density ρ1 is assumed to be uniform over the entire area A1. In the same way, V2 and ρ2 are assumed to be uniform over the area A2. In real life, this is an approximation. In reality, velocity and density vary across a cross-sectional area. I hope you would have understood continuity equation. Let us move on to types of flow in the next session. Thank you.